Good day. We're going to create a analysis or a simulation as it's known in Fusion 360. And so to do that, we're going to create an object. In this case, it's going to be a picture hanger, and apply some forces to it to see how much it takes to bend it and or make it fail. So here's what we're going to work on. First, we're going to create the picture hanger, and then we'll go ahead and apply that simulation. So to begin, let's go ahead and create a sketch. And so in this case, we're going to go ahead and create the sketch in the XY plane. Look at the front view. I'm going to go ahead and create an object. Most of the picture hangers are about 1.5 inches tall. They come down straight. And then they have a hook on the end, and then they have another straight component. So let's go ahead and draw a straight line about 1 inch long. We'll go ahead and create an arc. We'll do a 3-point. Start the arc at the 1/2 inch. Point 2 will come out about here, 0.7, 0.8, and we'll drag the arc into place. And that looks pretty good. Let's go ahead and offset these. And the thickness on this will be about 0.10. And we'll cap the end with another arc or a line, either way. So we can put an arc on this or put a fillet, either way. Whoops. Well, it'll work. And then the top, we're going to go ahead and draw a solid line across to close the entity. And if you want to see the dimensions on it, for some reason did not close that line. And here's the dimensions. So from the top to the center point, it's 1 inch, radius of a 1/2 inch, put a radius of 0.88, 0.87, we'll go 0.0, just to round it off. The thickness of the part is 0.10. Okay, so that's our basic shape. We might need to extend this, so instead of just 1 inch, we might need to make it longer, but that's our first component. We're going to actually add another piece on top of it, so we'll be fine. We'll go ahead and extrude this. So we'll finish the sketch. We'll extrude this. And right now, the extrusion distance is going to be about 0.2. And what we're going to do up here is we're going to go ahead and put another sketch on that flat surface here. We'll look at that flat surface, and what we're going to do is create some wings. So I'm going to go ahead and create a rectangle here. Bring it straight across. Notice how I highlight, and then I can bring this straight across. And dimension wise, 0.25. 0.75, 0.75, and that should work out a-okay. If we want to dimension it to the top of the line, we can. I can't because it is coincident, but If yours is not on the top of the surface, then you can go ahead and dimension that. We're going to go ahead and extrude it. So we'll finish the sketch, extrude. We'll take the two wings, extrude it back 0.10, or we could go actually in extrusion to the object. And the object is the back surface. And so that way it goes to that back surface and it doesn't go any thicker. We'll choose OK. And we'll have to drill a couple of holes here on each side. So the easiest way is that we'll use the hole command. We'll pick the front face. That's way too big of a hole. So 1/16 of an inch. The face selected here. We'll do 0.125. And from this front edge, we'll do 0.20. And so we'll have that. Now the diameter of the hole is 0.0625. The depth of the hole makes no difference. It's going to go through the part. And the distance of 0.125 and 0.2. And we'll do the same thing on the other side. And again, since we didn't put any dimensions in yet, and I picked it and it didn't go to the right spot, it's okay. We're going to go ahead and pick a reference top, 0.125. Pick a reference side, 0.25. Again, 0.0625 is our diameter. And choose OK. So now we've got our bracket more or less created. So now that we have this done, we have a single object. We're going to go ahead and save it. So we'll hit save. Class instruction. We'll go ahead and pick this under class instruction. And we'll call this hanging bracket, and we'll choose save. Alright, so now what we have is we've got our finished part. Now we're going to go into simulation. Now the simulation does cost money for companies. However, as an education student, you get the simulation for free. It takes credits, and each credit is worth $1 to run a simulation. And so the more complex or the larger size, it takes more credits to run. We're going to do a basic static stress, but you can see that simulations, we can do everything from thermal stress, structural buckling, event simulation, which actually is if we have an assembly and we wanted to place forces on that assembly, which is pretty amazing. And the newest one is the shape optimization, which is part of the generative design component, but this will lightweight the shape design. Not as dramatic as the generative design tools, but it actually will help you in your design optimization. So we're just going to do a basic static stress. We'll create our study. So they have a lot of really good videos that pop up on the quick setup here. Now, if your block is over here on the right-hand side of your screen, you're going to need to move this over or close the quick setup, either way, because the information that we're going to gain is actually going to show up on the far right-hand side of our screen. So there's basically three things that we have to set up for our design. Number one, the material. Number two, the fixed surfaces, the surfaces that don't move. And number three, the force location and the amount of force. So the first thing we're going to do is set up our material. Now it might already have a default material associated with it. So we're going to go ahead and choose Study Materials. And right now it's set up as a steel. We can change that, And so since most of these brackets are not steel but are typically a brass, we're going to go ahead and choose brass. They might also be aluminum. I've seen quite a few aluminum brackets, but typically we'll see a brass bracket. And so that's our first step, is to choose a material. And notice when I chose it, I chose the study material. The component was designed as steel. The second component is the constraints, and that's the fixed location. And so this particular object is going to have a constraint on either the back of the object or on the in the holes. So I'm going to first start off and constrain the holes. Alright, so the back of the body and the holes. So the back of the hole gets a fixed constraint. The back of this hole gets a fixed constraint. And we'll choose OK. We'll do the constraints command again, and this time we'll highlight the back surface here and make that a fixed constraint also. And what that does is that guarantees that when the hook is against the wall, that becomes a fixed object. Now you could actually choose the hole inside of the object as a fixed constraint also. And so those are the fixed constraint, and we can fix specific axes. So depending upon the XYZ of your icon, you can control what the fixed axis. So this is telling us that there's no movement in any axis. The third and final component is the load. And so there's two different types of loads. There's a force and then there's a pressure. There's also a moment, which is circular, bearing loads, remote forces, and then hydrostatic pressure. But typically we'll utilize for our basic operation, we'll just use a single force or a pressure, which is a surface force. So pressure is force along a surface. Force is a single point. And so I'm going to go ahead and choose the top of the object here. Now what I'm looking at is the arrow located in the proper direction? Is the force arrow pointing in the direction that we need to make it work? If it is, perfect. If it's not, then I need to change the angles of that particular force. Now the magnitude of the force and the units can be modified. So if we change force units from newtons to pound force, we can then put in 20 pounds of force. Or we can put in the appropriate newtons force. And so now that that's selected with a force and the arrow is pointing in the correct direction, I'll choose OK. So we're going to put 20 pounds on this. Now I don't know exactly what's going to happen just yet. We're going to go ahead and do a pre-check. The pre-check just says make sure that you've got the material, the fixed, and the force set up. And the study has all the information as the pre-check. So let's go ahead and solve it and see what happens. Now this is what happens when you choose solve. It's going to go out and it's going to actually calculate this out on the computer, and it's going to take 5 credits. So theoretically this will cost $5. However, as an education participant, you have unlimited cloud credits. And so we're going to spend our cloud credit of 5, and let's run the analysis. Now there are different times of the day that it could be busier and it may take a little bit longer to run the analysis. A more complex analysis will take longer to run, obviously, than a simple analysis like this, but it queues them up and then it runs the analysis in the order received. So here we go, we are now complete. So the actual minimum safety factor is 0.32, which is not very high. And so safety factors will give you a relative value. Safety factors of ladders are like 3x the associated weight. So the idea is that you want to have a high enough safety factor for it not to fail. This is This design expected to permanently bend or break under the current analysis criteria. So this is not designed for 20 pounds. But let's see what happens. So notice that I said that our information is over here, and it shows us where the highest stress areas are. And this happens to be the safety factor. We're interested in displacement. So the maximum displacement is over an inch. So this thing's going to move down over an inch, which is way too much. So being brass in the design that we have, just way too much. This would be not a 20-pound hanger. We would definitely need to increase the width and the thickness of this material for it to hold. So it's moving down 1.22 or 1.211 millimeters, not inches, my fault. We can change it into inches. That's one of the nice things that we can now do, is change it. So it's moving basically 0.04 inches. Okay, so 4/100ths of an inch, almost a 1/16 of an inch movement. So that was my error because the unit of measurement, and again, units are really key on seeing this, and so this is moving 0.04 down. Probably not enough to break it, but it will definitely bend it and provide that level of force. So if you had a really expensive painting and it weighed 20 pounds, this hanger probably would not be a long-term solution for you. Okay, so that is how you can create an object, run it through a simulation, and calculate how far an object is going to be displaced at the highest stress location. Have a great day. We'll be talking to you soon. Bye.